Hello again, everyone. So in this lesson, I want to extend what we've learned about trigonometry so far. This is where it really starts to get interesting and where we can start to solve real-life problems using trigonometry. So our learning objectives for today are going to be to find the sine, cosine, and tangent of an angle in a right angle triangle. Now that sounds really complicated, but it's actually very straightforward. It just involves dividing one of the sides by another one of the sides. That's all it is. And then we want to be able to use that to find the opposite or adjacent side given the angle and an appropriate side. So by the end of this lesson, we should be able to solve problems like this. If I just draw a picture. So you might have a ladder leaning against a wall, and you might be given, say, I don't know, maybe this angle is like 40 degrees. Maybe you know the length of the ladder. So let's say the ladder is, let's say it's 2 meters long. If you know that, then you could work out, then you could basically, if we know that, then we can use trigonometry. So sine and cos in this case, or sine to work out the height of the top of the ladder, so the distance between the base of the wall and the top of the ladder, or we could use it to work out the distance between the base of the ladder and the base of the wall. So it's quite useful. It doesn't sound terribly interesting, but it is useful and it's used in a wide variety of contexts. So without further ado, let's make a start. So to start with, I'd like us in our books, or if you printed out the sheets that I've put on Teams, I'd like you to label the hypotenuse, opposite, and adjacent of the triangles below, given the angles. So, we're given 30 degrees in the first one. I want you to label the opposite, adjacent hypotenuse. And then for question 2, I'd like you to find the length of the hypotenuse, if you remember, using Pythagoras' theorem. So if you pause the video now, have a go, and when you resume, we'll go over the answers. Okay, so let's go over the answers. So for the first triangle, what I should have labeled first actually are just the right angles in these triangles here. So they often won't draw the triangles to scale in questions, but they should always draw the right angles to indicate that these are indeed right angle triangles. So for the first one, we always start by looking at the hypotenuse. So we look at the right angle and we draw a straight line from it, an arrow, and the side that it points to is the hypotenuse, the longest side of the triangle. We now look at the 30 degrees, draw a nice straight line, an arrow, and we can see that is opposite the angle that we are given. That is the opposite. And the remaining side, the one that we haven't yet labeled, is the adjacent. That is our scheme for labeling triangles. So if we do the same thing, second one, hypotenuse, opposite, and adjacent. And the last one, hypotenuse, opposite, and adjacent. And for question 2, we are given a right angle triangle. We're given the 2 shorter sides, so we can use Pythagoras' theorem to work out the longest side, or the length of the hypotenuse. So remember, the sum of the squares of the 2 smaller sides is equal to the square of the longest side, or the square of the hypotenuse. I can label my triangle. I could say A and B for the 2 smaller sides, and I could write hip or C for the longest side. Pythagoras' theorem says A squared plus B squared is equal to C squared. Then I can substitute in 6 squared plus 4 squared is equal to C squared, which means that C squared is going to be 36 plus 16, which is going to be 52, which means that C is the square root of 52, which to 2 decimal places we'll say is going to be 7.21 centimeters. So all that should be quite straightforward. If it isn't, have a look at the previous video again to refresh your memory. So what I've got now is a little acronym, and you may have noticed this on the sheet, the follow sheet that I've attached in Teams. Less is more. So this is what we should think about when we're doing trigonometry. The L stands for label. So whenever you're doing a trig problem, label your triangle first, your right angle triangle first. E is for equations, because there are a couple of equations, but they're really, really simple, and you can remember them with a really nice mnemonic, SOHCAHTOA. So label your triangle, get your equations, then S is for select, because you've got to select the appropriate equation for the situation, and then the last S is for solve. Solve your equation. So we will be using this once we've established what the trig ratios actually are. I'm just going to move on, we'll come back to that. So what you should see now, if you're following it, straight from your book, that's fine, or if you're following from the sheet, we're going to go through some examples now of finding the sine, cosine, and tangent of the angles labeled. So for example number 1, this one here, we want to work out the sine, cosine, and tangent of the angle theta. So that is not a 0, that is a theta. It's just a letter that we use for angles, a Greek letter. Now, to do this, so you may have seen the sine, you may have seen on your calculator. So if I just get my calculator on the board, this is the right one. You may have seen sin, cos, tan on your calculator. And basically today, that is what we're going to be looking at. So what we need to do is remember SOHCAHTOA. So write that down, etch that into your memory. Just remember that mnemonic, SOHCAHTOA, because that gives us what the trig ratios actually are. So the first one is for sine. The sine of an angle, so the sine of the angle theta in this question, is going to be the opposite, that's what the O is for, divided by or over the hypotenuse. That is what the H is for. So let's look at our triangle. Well, we know that the hypotenuse is 5 centimeters because it is opposite the right angle. We know the opposite is 4 centimeters. And we know the adjacent is 3 centimeters. So if I want to work out the sine of the angle theta, it is just the opposite, which is 4, divided by the hypotenuse, which is 5. So that means sine, and again, I just write it as sin. We don't include the e just because we want it to be shorter. Sine theta is equal to 4 over 5. Now, cosine of theta, you may have already guessed it, cos theta is equal to the adjacent side from theta divided by the hypotenuse. So you can see here, SOHCAHTOA, and there's a reason I've written it in this sort of weird triangular way. Some of you may have already guessed why, and that's formula triangles. I've written it this way because it can be fit into a formula triangle, but we're not really going to be using it that way. We've got an easier way of working with it. So cos theta is adjacent over hypotenuse. So if we look at our example, the adjacent is 3 centimeters. So we have 3 over 5. And then tan theta. So tan of theta, I'm putting the theta in brackets because sine, cos, and tan are what we call functions. Nothing complicated there. Basically, they take theta and they spit out these numbers on the right. So sine of theta is 4/5, cos of theta is 3/5, and tan of theta, well, tan of theta is O over A, opposite over adjacent. So write down these formulae a couple of times till they stick. Sine theta, opposite over hypotenuse, cos theta, adjacent over hypotenuse, tan theta, opposite over adjacent, which in this case is just going to be 4 over 5. So it's really abstract. isn't it? We don't know, why do we call this sine? Why is this called cos? Why is this called tan? Where does all this fit in? Well, I'm going to basically say, for our purposes, all you need to do is remember SOHCAHTOA and be able to write these ratios down correctly. So if you can understand why I've said sine theta is 4 over 5, because, opposite is 4, hypotenuse is 5, that's fine. I will explain it in another video, which I will link you to if you are interested in where these ratios actually come from. And I'll just very briefly just say they all come from what we call the unit circle. So all that is a circle on a graph with the middle being the origin. So, what we'd call 0, 0. We take like a stick, or we take the radius, which is going to be 1. So this is a special circle with radius 1. And we just imagine that we turn the stick anti-clockwise around the circle, sort of like a clock, but going anti-clockwise. And we get different values. And the height of the triangle that is formed gives us the sine. The base gives us the cos, and the ratio of the height and the base gives us the tan. That's where it comes from. But we don't need that for this stage, so don't worry too much. So, for example 2, we want to find the sine, cosine, and tangent of angle alpha. So, same thing again. We're going to label our triangle. That's our L in our little mnemonic. We're going to label it. So, opposite the right angle is the hypotenuse. Opposite the angle that we are given is we're given the angle alpha, because I've asked you for the sine, cos, and tangent of angle alpha. So that is the opposite, and the adjacent is then 35. No units, because they're going to cancel out anyway, but usually we'll give you units. So we've labeled it. Let's look at the equations now. So the equations are SOHCAHTOA. Always write that down. So that means that sine of the angle, in this case the angle is alpha, is equal to the opposite to that angle, which is 12, over the hypotenuse, which is 37. Cos alpha is equal to the adjacent divided by the hypotenuse. So that is 35 over 37. And tan of alpha is equal to the opposite divided by the adjacent, 12 over 35. You can leave them like this because we have scientific calculators, so that's fine. So move on. Example number 3. That should say 3. I don't know why that says 2. That should say 3. So we want the sine, cosine, and tangent of B. So we're looking at sine of, well, before we do that, let's label it. So opposite the right angle is the hypotenuse. Opposite the given angle is the opposite. And then the remaining side is the adjacent. So let's write, so we've labeled it, we've done our L. Now we're going to do the E, write on the equations. We don't need to select or solve yet because we don't want to find any unknown sides. So we're just looking at L and E of less is more. So we've labeled it, equations, so SOHCAHTOA. Okay, so working out the sine of angle beta. Sine of beta equals, right, opposite 3 over hypotenuse 5. Cos of beta is going to be the adjacent to beta, which is 4, over the hypotenuse, which is 5. And then tan of beta is equal to the opposite to beta, which is 3, over the adjacent to beta, which is 4. So the reason we're working these out is because sometimes, if I just think about an example, you might be given, so I'm just going to highlight it, you might be given beta, but you're not given, say, 3. You're not given the, in this case, the opposite. Well, if you are given beta, then you can use your calculator to work out what sine beta is, and then you can find the number here just by remembering what we learned about when we did equations. We're going to do that towards the end. Just for now, let's continue calculating these. So at any stage during these examples, you can pause the video, work it out yourself, and resume it. It's like, you can think of it as extra questions then. or you can just keep watching until you feel confident. So let's find the opposite, not the opposite, let's find the hypotenuse here. So we're labeling our triangle, hypotenuse. Oh, well, this looks a bit different, doesn't it? Because they haven't actually given us the hypotenuse. Well, let's carry on labeling first. So the opposite we can see is 24, and the adjacent is 7. And once again, I want the sine, cosine, and tangent of my angle alpha. Now, you should notice the problem here is I don't have the hypotenuse. So, if I worked out sine of alpha, I'd be saying, right, sine of alpha is the opposite, which is 24, divided by the hypotenuse AB, which I don't know. Well, how could we work out the hypotenuse? We've got a right angle triangle, got the two smaller sides. Should now remember that we need to use Pythagoras' theorem. So the square of the hypotenuse, so AB squared, is equal to the sum of the squares of the two smaller sides. So I could say AB squared equals BC squared plus AC squared. Or probably better to write like this, AC squared, that's just this side here, this 7 squared, plus BC squared. And that's often the way you'll see it written. We can now substitute in to find AB, which is the hypotenuse. Well, AC squared is going to be 7 squared, and BC squared is going to be 24 squared. So plugging that into our calculator will give, so we have 7 squared plus 24 squared equals 625. And then obviously we're going to get 25 now, because if we square root both sides, we get rid of the square on the left. So we end up with AB is equal to the square root of 625, which is, I'll just prove it to you, square root of that is 25. So that means the hypotenuse is 25. And we can now work out the sine, cosine, and tangent. I'll give you a sec if you want to write that down. If not, I'll just rub it out now. So to work out the sine, cosine, and tangent of the angle alpha, we just need to use 25 as the hypotenuse. So we have sine alpha is equal to opposite over hypotenuse, which is 24 over 25, so very close to 1. Cos alpha is equal to the adjacent, so 7 over the hypotenuse 25. Tan alpha is equal to the opposite over the adjacent, so 24 over 7, and that is that. We don't need to convert these to decimals or mixed numbers, that is fine. So those are the examples. What I'd like you to do now is do a little exercise on your own. I want you to find the sine, cosine, and tangent of the angles labeled in the triangles. So for the first one, I want sine x, cos x, tan x. For the second one, I want sine y, cos y, tan y. And for the third one, I want sine 30, cos 30, tan 30, and sine 60, cos 60, and tan 60. Okay, so hopefully you paused the video and had it go. Let's have a look at the answers. So for the first one, you should have sine x is equal to, so obviously, but before you've done anything really, you should be labeling your triangles, hypotenuse, opposite, adjacent, you should be labeling. So that's the L, you should be writing the equations. We don't need to solve these, so it's just a case of labeling and then writing the equations. So for the first one, you should get sine x is 6 over 10, which you could simplify to 3/5 if you wanted to. Cos x should be 8 over 10, 4/5. And tan x should be 6 over 8, which is 3/4. 2, we get sine y is equal to 4 opposite over hypotenuse, 4 over 7.21, which you could simplify if you wanted to. You could, but I'll leave it like that for now. Sine y is opposite over hypotenuse, 4 over 7.21. Cos y is adjacent, 6 over hypotenuse, 6 over 7.21. and tan y is equal to the opposite 4 over the adjacent 6, which you can simplify to 2/3. Finally, we have question 3. So this time I've given you numbers, and I've basically given you a triangle which will satisfy these conditions. So this, to 3 decimal places roughly, this triangle is a real triangle. If you were to draw a right angle triangle with base 1 and hypotenuse 2, the other side would be 1.732, roughly, to 3dp. So we have sine 30 degrees, so sine of 30 degrees, same strategy. Label our triangle, so the hypotenuse is 2 because it's opposite the right angle. The opposite is 1 because it's opposite the angle that we are given. We are looking at 30 first. And then adjacent to the 30 is going to be 1.732 because that one has not yet been labeled. So sine of 30 degrees is going to be the opposite over the hypotenuse, which is 1/2. And that's actually a really nice one to remember. Sine 30 is a half. Sine of 30 degrees is a half. And if you want to find out really why that is, well, if you want to know why that is, if you drew this triangle yourself, so base of 1, hypotenuse of 2, the other side would then be forced to be this, you would get sine 30 as a half. So cos 30 is going to be the adjacent, which is 1.732, over the hypotenuse of 2. So, you can work that out in your calculator. So 1.732 divided by, adjacent over hypotenuse over 2 gives me 423 over 500, which is 0.866 roughly. And then tan 30 is equal to the opposite. So tan 30 is going to be 1 over the adjacent of 1.732, which if you work it out on your calculator, you will get, 1.732. Oh, my apologies, 1 divided by 1.732. We get about 0.577. I use 3dp in the question, so I'll use 3dp in the answer. There we go. And just as a bit of interest, if we use our calculator, so obviously for this question, you'd have to show these workings because I've asked you to use the ratios for it. But if you actually type into your calculator, making sure that you're in degree mode, not radians, that's something else. If you typed in sine 30, you get a half. If you type in cos 30, you will get root 3 over 2. And if you press SD, you get 0.866 to 3dp, which is what we have. And then tan 30 is root 3 over 3, which is 0.577 to 3dp. So you can see that the calculator remembers the values, the same values that we worked out there. And then let's give you the answer now. For this one, sine 60, you will get opposite over hypotenuse. You'll end up with root 3 over 2, which is 1.732 over 2, which is going to be 0.866, just like the cosine. Cos 60 is going to be a half. And tan 60 is going to be root 3 exactly, which is 1.732 over 1, which is 1.732. And you can see there's an interesting relationship between sine 30 and cos 60, cos 30 and sine 60, and also between tan 60 and tan 30. So just have a think about that. It is quite interesting how all these things relate together. And the more trigonometry you do, the more you'll see the reasons why. So hopefully these are okay, and we'll be ready to move on to some actual interesting problems. So now we're looking at finding missing sides. So this is where trigonometry gets really interesting. This is where you can find things like, so let's imagine that you are on a cliff, just on a nice, having a picnic or something, hopefully not too close to the cliff edge, that'll be quite dangerous. On the base of the cliff, so from where the ship is out to sea, and the cliff, so maybe we know how far the ship is out to sea, and we know the angle between the ship and you on the top of the cliff there. So maybe you know that angle is like, I don't know, 60 degrees. Maybe you know this distance here, so you know, or maybe you don't know that distance there. Maybe you know how, so you want the opposite. So maybe you want to know, there we go, we can do that. Maybe you want to know how high the cliff is. So, you might know how far out to sea it is. Let's say we're 200 meters out to sea. And then you want to know how high the cliff is. Well, we can use trigonometry to do that. So these are really useful tools if you want to do any engineering or anything like that. And we'll look at a similar problem to that one later on. So first of all, we want to find, for example 1, we want to find the missing angle. Not the missing angle, sorry, that's going to be in a later video. We want to find the missing side. Find the missing side. So I just labeled it with a question mark. I'm going to call it, well, it doesn't matter what we call it really, just want to find the missing side. So this is where we really put the less is more mnemonic into effect. So less, we're going to label our triangle. So let's do that first. So you should be really good at this now. So opposite the right angle is our hypotenuse, which is 6. I could put 6 equals hypotenuse, or hypotenuse equals 6. Opposite the given angle is the opposite. So I'm going to say op is going to be my missing side. And then the adjacent is going to be the remaining side, which is just this one here, this BC. Okay, great. So we've labeled our triangle. Now let's look at the equations on offer. That's the E in less. So equations. So the equations for trigonometry, whenever you have a right angle triangle, obviously you've got Pythagoras' theorem, which is one to keep in mind. But the main one, when you've got angles or angles are involved, are SO, Ca, TOA. And just to remind you what that means that sine of the angle, so sine of theta is opposite to theta divided by hypotenuse. Cosine of theta is adjacent to theta divided by the hypotenuse. And tan theta is equal to the opposite to theta divided by the adjacent to theta. It's the only one which doesn't involve the hypotenuse. So we've got our equations. We're happy with these. We've learned these because they won't give you these. So now we want to select the equation that we want to use. Now this is probably the most tricky step, takes so much practice, but it really isn't that bad. So we want to select the equation to use. So we go back to 1, we look at how we've labeled it, and we see what we have and what we want to work out. So we have the hypotenuse, we have what we've called H, and we want the opposite, the O. So we want the opposite, we have the hypotenuse. So these two are the sides that I really care about. These are the sides that are relevant to us. So wherever I see that in my SOHCAHTOA, my SOHCAHTOA equations, I'm going to give a tick. So, right, first ratio, I have the opposite, I have the hypotenuse. Second ratio, this one, adjacent, well, it's not relevant to me. Hypotenuse, okay, that's relevant, I give it a tick. For the tan, well, opposite is relevant, adjacent is not. So I look at my 3 ratios, and I see that in the sine ratio, I have ticked twice. So that is what I'm going to circle, that is what I'm going to use. So we have selected the sine ratio. That is what we're going to use. So now we have to solve. So we actually have to solve an equation, but it's very, very basic. So we just have to write sine of the angle. So the angle is 50 is equal to opposite divided by hypotenuse. So again, I look at my question. The opposite, I do not know. That is my unknown. And my hypotenuse is 6. So I've actually written an equation now, which I can solve. So I know I have sine 50, so sine of 50 degrees, I should say, is equal to something I don't know over 6. Now, I want that question mark. I want to find that. So I need to remember solving equations, specifically a one-step equation. Well, solving equation is all about getting the unknown on its own So I need to essentially get rid of that 6. I'm going to use a different color. Now, have a think, what are we doing to the 6 on the right-hand side? Well, we're taking the unknown and we are dividing it by 6. So if I want to get rid of it, I've got to do the opposite of divide. So on the right-hand side, I would have to multiply by 6, because that would cancel the 6 on the bottom of the fraction. I'd have 6 over 6, which would be 1. But if I've multiplied the right-hand side by 6, I need to balance my equation. I've got to multiply the right-hand side by the same. So I need to do 6 times sine 50 is equal to my question mark. And these are the workings that you'd have to show. And on a calculator, on a modern scientific calculator, so we used to work out sine 50 and then times. On a modern calculator, you can just get away with it like this. You can just do 6 times sine. Can I make this bigger? That's fine. 6 times sine 50, and just close the bracket to be sure. Again, making sure in degrees equals, and then that would be your answer. So 4.596, so about 4.60 to 2 decimal places. So I would say question mark equals 6 times sine 50 degrees, which was 4.596. So I'd write down the whole thing, so 4.596 and so on, and I would say that's roughly 4.60 centimeters. Let's do another example. So, make sure you've got this down. Pause the video if you need to. Let's do another example. So this time, I want to find the missing side here. I'm going to go through a little bit more quickly because I think we're more comfortable with it now. We're thinking less is more. Right, first we label the triangle. Let's label it. Opposite the right angle is the hypotenuse. Opposite the angle is the opposite. I don't know that here. That's my unknown. And then the remaining side, which I have not yet labeled, is the adjacent. Great, we labeled it. Let's think about the equations. Right, the equations that we have are sine equals opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Great, so we've got our equations. Now let's select the equation that we want to use. So I have the hypotenuse, no, I don't have the hypotenuse, my apologies. Sorry, I have the adjacent and I want the opposite. So those are the sides that I really care about. So let's look at the equations. Well, in my first equation, I have opposite hypotenuse, so I can tick it for the opposite, but nothing else. Second equation, I have the adjacent, but not the hypotenuse. Third equation, I have the opposite and the adjacent. This is the one that I use. So that means I'm going to use, so this is now I'm going to solve my equation, or write my equation and then solve it. I'm going to use tan of my angle, so that's 37. Tan of 37 is equal to the opposite to 37, which I don't know, but that's fine. The question mark over the adjacent, which is 3. I want to have the question mark on its own, so I'm going to multiply both sides of my equation by 3 to cancel out the 3 on the right. So I'm timesing both sides by 3, or we could think of it as 3 over 1 if you wanted to. On the right-hand side, that is going to cancel out. So I am left with question mark is equal to 3 times tan 37. If this multiplying both sides business is confusing, you just think I'm dividing by 3 on the right, so to get it on the left, I multiply, if you want to think of it that way. Floating thing if you want to. So I have my question mark is 3 tan 37. So make sure you've shown the examiner all of these workings to get all the marks. Now let's put it into our calculator carefully. So I have 3 multiplied by tan 37 equals 2.26066215. So, and then 0.6615. So I get 2.6, if we do 2 decimal places, 2.61. I haven't been given any units, so 2.6122 dp. Remember, if you are given units, make sure you give the appropriate units in your answer. So we'll do one more example, then you can, or we've got 2 more examples, and you can do some questions. If you want to pause the video and have a go at these examples on your own, that's fine. Or if you just want to skip to the questions, again, that's fine. Up to you. So, label. So we have the hypotenuse, we have the opposite, and then the adjacent is going to be there. So we've labeled equations. So, ka, toa, and then select the equation. So in this question, I want the opposite. I have the adjacent. So that means it's O and A that I will tick. So only have O. I have A but don't have O. O and A. So again, this is going to be a tangent problem. So now I want to write my equation and solve it. Tan 65 is going to be the opposite to 65, which is unknown, over the adjacent to 65, which is 7. I want to get rid of the 7 to leave the question mark on its own. To do that, I would have to multiply both sides by 7. So I end up with the question mark being 7 times tan of 65 degrees. And once again, let's put it in. So I get 7 tan 65, should be about 15. Let's check that. 7 times tan 65, about 15. So I get, usually they'll specify the accuracy. Just one thing, only round when you're at the end. So I'd say 15.011. You don't need all of this accuracy, but it's a good habit not to round till the end. So I would get my question mark is going to be 15.01 to 2 dp, 2 decimal places. So one more, and then you can have a go at some questions on your own. So label, hypotenuse 16, opposite is the height of the triangle, which is not given, and then the adjacent is the base of the triangle, B. So this time I don't want you to find a question mark, I want you to find B. So you've labeled our triangle. Consider the equations. So write those down first. So we have so, ka, toa. So now let's let's select our equations. That's a good save there. Let's select the equation. So we have, in this question, we want to find the adjacent. So we care about A, the adjacent. And then we are given the hypotenuse. So let's look at the equations. Right, sine, I have the hypotenuse, but nothing else relevant. Cos, I have the adjacent and the hypotenuse. And toa, I only have the adjacent. So, and had the opposite, but that's not what I'm giving here. That's not what I want to find either. So cosine is what I'm going to use because I've got 2 ticks. So we select cos 65. So we're forming our equation now. Cos 65 is equal to adjacent over hypotenuse. So the adjacent is B and the hypotenuse is 16. So now I need to multiply both sides of my equation by 16. So doing that will give me, on the right-hand side, it will cancel the 16s, leaving me with B, which is what I want. You know, just think to yourself, if I have, I don't know, 8 times 16, and then I divide it by 16, what's that going to be? It's just going to be 8. 16s cancel. So I have B is equal to 16 times cos 65. Let's put that into our calculators. So we have 16 times cos 65, close bracket, equals. So the reason I'm closing the bracket, by the way, is just to remind you that I'm doing cos of 65, so I'm working that value out, and then multiplying the result of that by 16. I just want to make sure you keep that in your mind. You know, I'm not doing cos of 65 times 16. I'm not doing this. I'm not doing, you know, cos 65 times 16. That would be a completely different answer. So I'm doing 16 times cosine of, not doing that, I'm 16 times cosine of 65, which is 6.76189188. So, you know, really you don't need all this accuracy, but it's just to get into the habit of only rounding at the end. which gives you B is equal to 6.76 centimeters, because those are the units, to dp. Okay, so hopefully after these examples, when you hopefully fill these in on your sheet as well, just for your revision, so you can look back. Hopefully now you should be quite comfortable with finding the adjacent or the opposite, given the appropriate unknown sides or angles. So I'd like you now to have a go at exercise 2. I want you to find the missing sides of the triangles given below. So on the sheet, I've given you the mnemonic to help you. You've got the equations. Have a go, pause the video, and then when you're ready to go for the answers, press play. Okay, so first one. I'm just going to go through the answers quickly. I'll do the first one in detail, then I'll be a bit more quick. So the first one, again, less is more. Label our triangle. So we have the hypotenuse is 5. We have the opposite, what we want to find, because obviously that's a missing side. So that's what we want to find here. Oh no, I'm sorry, I'm being a complete idiot. Sorry, we don't want to find that. So we know we label it as the opposite, but obviously we want to find what I've put here as a question mark. So the adjacent is what we have left, and that is indeed what we want to find here. So we've labeled equations, so ka toa. You select the one that you want. We want the adjacent. We have the hypotenuse, so that means we're going to use cos, because obviously I've only got the one tick with the sine, the one tick, the adjacent with the tan, 2 ticks for the cos, so that's what I'm going to use. So we write down cos of 30 is equal to the adjacent, which is unknown, over the hypotenuse of 5. To get rid of the 5 on the right and be left with what I want, my unknown, I just multiply both sides by 5. Leaves me with question mark is 5 times cosine of 30 degrees. And if I put that into my calculator, so I'll just show you, we get 5 times cos 30 degrees. You get this 5/3/2. That's what it is as an exact number. To get it as a decimal number, we just press SD. We get 4.33 centimeters to 2 dp. Okay, so I'm just going to quickly go through the other ones. In fact, I'll just edit this bit out, but that's fine. So second one, we end up with, what's that, 9 cos 19, cos, Jason hypotenuse. 9 cos 19, which is cos 19. 8.510. This one I get 10 sine 50. Sine 50 is, no I don't, I get tan 50 is opposite over adjacent. I get the opposite equals 10 tan. I get 10 tan 50. .92. And then the last one we get cos sine 40 is equal to times sine. Okay, so these are the solutions to the other ones. So we should have 8.51 centimeters, 11.92 centimeters, and then 5.14 centimeters. So hopefully this didn't cause too much difficulty. If obviously it's not making sense, have a look back at the explanations in the previous parts of the video, or just let me know on Teams. Finally, let's do a little plenary just to see where this can be used in real life. So we have a ladder. So the ladder in the picture is 6 meters long. So I'll just label that. That's 6 meters long. Or in fact, if you want to give this a go just on your own now, just pause the video, give it a go, and then I'll go over it. So I'll just give you a little bit of help first if you want some. So the ladder is 6 meters long, so that's the actual ladder here, 6 meters. The angle between the ladder and the ground, so the ground's here, obviously, and the ladder's there, so that angle is this one here. And we're given that that is 70 degrees. We want to know how far from the wall is the foot of the ladder. So this is very much like the the question with the cliff and the boat earlier on. We want to know, well, it's not exactly the same because that was for the height, but it's similar. So we want to know how far from the wall the foot of the ladder is. So we want that. So see how you can model this as a right angle triangle, because I shouldn't have to remind you that the wall and the floor are right angles, making this a right angle triangle. See how you can model it as a right angle triangle to find the missing side. Okay, so hopefully you've had a go. Let's go over this. So if I just draw this a triangle quickly, a bit more neatly than I can do freehand. So it will look something like, none of these are to scale or anything. So we have, so I'm going to say that is 6 meters. I'm going to call that unknown side X. That's 70 degrees. So less is more. L, let's label our triangle. Opposite the right angle is the hypotenuse. Opposite the given angle is obviously the opposite, and then adjacent is the one that we haven't yet labeled. So we've labeled our triangle. Think about the equations. Sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. Let's select our equation. Right, I'm given the hypotenuse and I want the adjacent. So I'm given the hypotenuse, so tick the hypotenuse wherever that comes up. I want the adjacent, so tick the adjacent. Well, cosine I've ticked twice, so that is the one that I'm going to select. Let's form our equation. Cos of 70 degrees is equal to the adjacent, which is x, over the hypotenuse, which is 6. How do I get x on its own? Well, multiply both sides of my equation by 6, which will give me x equal to 6 cos 70. So let's do that. 6 times cosine 70 equals 2.052, or about 2.05 meters to 2dp. Don't forget the units. So that means that the ladder, it's not a very good penmanship there. So that means the ladder is about 2 meters. The base of the ladder is about 2 meters from the wall, which, if you picture that in real life, the ladder is 6 meters long. So it makes sense because it's 70 degrees. That's quite a steep angle. So that means that the base of the ladder isn't going to be that far from the wall compared to the length of the ladder. So it's quite a sensible solution. If you were getting like, 14 meters or something like that, that wouldn't make any sense because that would be longer than the ladder itself. So that's all there is to finding the opposite and adjacent given the appropriate size and angles. In the next video, we're going to be looking at finding. In the next video, we're going to be looking at situations, for example, where you have sine theta opposite over hypotenuse. You're going to be given theta and the opposite, and you're going to want to find the hypotenuse. It's very, very similar. There's just an extra step of rearranging in a slightly different way, but that shouldn't cause any issues. So thank you for your attention, and I will see you next time.